Mistika incorporates a point-based tracker. So in this tutorial we'll go through everything to do with motion tracking. The concept of tracking in Mistika is pretty straightforward. Once we're in the visual editor, we take a shot or the result of some effects into the tracker here. Then in the tracker we select something to follow and create some tracking data. This tracking data is then free floating. It's just positional information, and we can send this positional information to any effect that can receive it, and that essentially is any effect that itself has some form of positional control. So for example, if I were to add a title to this, then I could return to the tracking. The tracking window always remembers what you did last. And then because I have the title effect highlighted, its parameters come up here. So to pass the tracking data to the title effect, I simply select the folder that has the positional information in it, and then apply. In this case, I'm going to apply move. So now we can see the parameters are changing, and our title has received the tracking information. So let's firstly look at getting a shot into the tracker. As we saw, it's pretty straightforward. We can just double click on a shot, and once we're in the visual editor we can go into tracking. But it doesn't have to be a neat shot. For example, we might find that our tracker would work better in some instances if we initially color corrected it, in which case we can take the result of the color corrector into the tracker. Or perhaps we might want to denoise, degrain the shot before we track. However, there are two things to watch out for. One is that if we have a number of processes on our stack, then as the tracker works it has to run those processes in order to get the resulting image. So that will make the tracker run slower. So generally, if you don't need those processes to help your track, then take the neat shot in. The other thing to watch out for is anything that adversely affects the tracking. So for example, here I've got a framing node. So what I'll do is create a piece of animation in the framing node. So our shot is now doing this. So if I were to take the result of the framing node into the tracker, then obviously the trackers are now going to follow the combined move, which is the animation that I've created plus the natural movement in the shot. Now this might be what I want, but it's also sometimes the root of a mistake that we accidentally track something that we've affected ourselves, so therefore our tracking data isn't true to the original shot. Okay, let's just go back to that title example. And we'll delete this tracker. So let's just look at what a tracker actually is. So if you see no trackers on your screen, the little squares, then we can simply click Add Tracker, or we can just press the keyboard shortcut of Insert. And firstly we'll see a blank rectangle with a T and a number. T means tracker and 0 is the number of the tracker, because we can have multiple trackers on the screen. We can move the tracker to a given location just by dragging from inside the square, and you'll see that a circle has appeared. The circle appears on any frame where tracking information has been recorded. And that tracking information can be recorded either by running the tracker or by manually moving. So for example, if I now jog on to the next frame, we can see that we don't have a circle because there's been no input here either by running the tracker or by manual intervention. But as soon as I move the tracker, we'll get a circle to show that a keyframe has been generated. The tracker is actually looking for the pixels that match the pattern inside this box. So we can change the size of this box by dragging it around. The smaller the box, the faster the tracker will be. So the tracker is trying to find this pattern of pixels in all the subsequent frames, and the pattern that it's looking for is modified by this history function here. If we set the history to 0%, what we're saying is that we're specifying a pattern of pixels to find, and throughout the frames of the shot, that pattern should be able to be found exactly. If we set the history to 100%, what we're saying is that throughout the tracking, that pattern is going to be changing. For example, the light might be changing over it, in which case the tracker should modify what they're looking for on a frame-by-frame basis. Any value in between allows us to bias how much history is used. When we're looking for something to track, ideally we're looking for a nice contrasty point. For example, this would not be a good tracking point because there's very little detail in here that says that this is a unique position. For example, this area where we've gone from yellow to green is very similar to this area, so the track isn't likely to be very accurate. On the other hand, a nice edge like this, or any of these marks would be perfect trackers. As the tracking moves on to the next frame, by default it will search the whole frame for the pattern that's here. We can restrict that search using the search zone here. If we switch it on, we get a second box. And what this second box means is we're helping Mistika by saying that when it goes to the next frame, the pattern it's looking for will be in this area. And you can see we can move this anywhere. The benefit for having search zone on is it will speed the tracker up, although the tracking's pretty fast anyway. But also it helps to narrow down the search, and that's particularly useful if you're tracking something that has a repetitive pattern, where perhaps this particular pattern of pixels might reoccur in different parts of the frame and cause the trackers to jump around. However, in many cases you don't need it. The one other item that restricts where the trackers work is this safe area here, which is specified by this slider. The point of the safe area is for when trackers follow something off the edge of the frame. With no safe area, what can often happen is the tracker will hit the edge and then start jumping up and down, perhaps as it finds some noise on the end of the frame. What we can do then is give ourselves a safe margin, and then what will happen is if the tracker follows something off the frame, as it goes outside of the safe area, it will cease to track. Rather, it will predict the motion of the item it was following based on its previous move. So with a smaller safe area, you're more likely to get a reliable track that follows off the screen. So having chosen our item to track, we can then tell Mistika to track forward from the frame we're on, backwards from the frame we're on, or in both directions, in which case it will do one and then the other to give us a complete sequence. We can stop the tracking at any point. We can track just one frame at a time. So this is now tracking just one frame rather than tracking the whole sequence. We can also restrict the ranges between which the tracker will happen. So for example, I could say I don't want to track before frame 10 and I don't want to track after frame 35. And you can see it restricts the range here. When we've tracked a shot, we can see that we've created a path. So this shows us where the trackers are followed. If we move a tracker, we create a manual intervention. Which can be quite handy if the tracker is momentarily lost. We can also change the point that we're tracking. For example, I'm going to track backwards from frame 20. So now I have a track, frame 20 following that point. As you can see, it doesn't follow thereafter. Let's imagine that at frame 20 this point now vanishes. Perhaps something comes in front of it and we can't see it anymore. If we hold down Alt and drag, we can drag the tracker to a different location. And so long as we're holding Alt, what we're saying to Mistika is we still want to track this point, but we'll do it by recognizing this pattern. So now if I track forward from that point, you can see that we're still building this tracking point here, a consistent curve from this point, even though before frame 20 we were tracking here, and after frame 20 we were tracking here. So we saw that by saying where we want to send our tracking data and then applying the move, we can send the data to a given item. And at the moment you can see that the tracking text is following the position of this. It's got an offset because within the title effect the whole curve can be offset. But what you'll also notice is the word tracking is only following the positional information. It's not rotating, it's not changing angle in the same way that our tracking point is. The reason being is that with one single tracking point, the only information we can get is XY position. However, if we add two tracking points, Mistika can measure the relationship between the two to get scale and rotation. So for this, let's do a slightly different setup, just to show a couple of different things. So I'm going to take my title, I'm just going to delete out any tracking information in there so it's nice and still. And instead I'm going to composite it with Comp3D, just for a different place to send tracking data to. So let's take this shot into the tracker. So now I'm going to insert two tracking points, say one here and one over here, and track in both directions. So now we can see we've got a line between the two, and it's that line that Mistika can use to measure the angle change. So if we open up Comp3D, and I'm going to send the tracking data to the axis 2. But now that we've got more than one point, we can see that the apply to options have opened up to give us rotation and size as well. And we can apply the data of those individually. But in this case I'm going to take all three and go apply. So now we can see that we've got rotational movement as well. Because in the axis we can see that the motion tracker has exported a full curve, which is very useful because this is a normal curve that we can edit and move around and do what we like. While we're in the Comp3D, let's look at the effect of zooming our shot. Let's look at the hierarchy of axis 1, 2 and layer. So at the moment our text is happily tracking with the object. If I were to go into layer 1 and zoom, you can see that the tracking text is still happily following. So let's just go back to 0 on there. If I do it in axis 1, we can see that the tracking text is, at first sight, appears not to be locked anymore. The reason is, in the hierarchy of these, is the motion tracking data in my instance, I applied it into axis 2. So as the position is moved around, it obviously moves the text by a given amount. However, because I've put a zoom in after it, this is near double. So effectively it's doubling the movement that's being applied here. So what we're getting is an exaggeration of the motion. Whereas when I did the zoom in layer, the zoom happens to the type before the motion data gets applied. So we're only zooming the tracking text, we're not zooming the motion tracking data. This is why generally I'll apply my motion tracking data into Axis 2, because then I have the opportunity to zoom or make alterations before and after. And while we're in Comp3D, let's just look at one other aspect that affects tracking. So I'm going back to the timeline and I'm going to duplicate this 3 times. And I'm going to duplicate the folder as well. So now I have 3 tracking words on top of each other. So let's move the second one up a bit and the third one down a bit. And we can see they're all happily tracking together because, as we know from the previous tutorials, any movement in Axis moves all of these together. But now what I'm going to do is move them in Z. So I'm going to move the top one back away from the camera. And I'm going to move the bottom one closer to the camera. And now when I move, can you see we have relative motion between them? Only the middle one is still tracked to the image. The one in the foreground seems to be moving too much, and the one in the background is not moving enough. The reason is the amount of motion that's being applied in Axis 2 is assuming that our layer is at 0 in the Z position. As soon as we bring a plane closer to the camera, as in real life, anything closer to the camera will have a greater apparent movement for a given motion. So this is something to watch out for. If ever you track something and mysteriously it's not following, it could well be this. But it's also something you can use for effect. If I wanted this piece of graphic free floating in front of the handlebars, this is how it would move. Okay, let's just return to the tracker to look at some other concepts. So what we're trying to do when we're in tracking is we're trying to build a curve that contains our motion data. Now so far we've built that curve in one go because our tracking points have been nice and clear and we've been able to track the entire shot. It isn't always possible to work like that, in which case we can also track a bit at a time. For example, let's say this point here was only visible, in this case the first 15 frames. So I can set a limit and track forward. So now I've got the first 15 frames. Now let's say it's not visible again until frame 35, but then is visible until the end. So now I could refine the point manually and track backwards. So now what I've done is I've built 2 halves of a curve with no data in between. And as you can see, what Mistika will naturally try and do is just straight line between those 2 points. So now if I export that, let's just first delete the curve that we had in there so we don't get confused. What we can see is the tracker has exported only the frames that have been keyframed. So that gives us the opportunity then to manually intervene if we want to. For example, to add in positions that otherwise couldn't be seen by the trackers. We can do it on the curves here, or of course just by moving with auto key on. We can also actually do it by manually adding in a keyframe. So the key idea is we're trying to build this curve which will then export, and it's ideal if we can build that curve in one go. But if that's impossible, we can build it a bit at a time by tracking different parts of the shot, or possibly doing some of it manually. So far we've only looked at applying a move. Let's look at stabilization. So to do that, I'm just going to go back to my timeline, just delete everything, just go back to our raw shot. And I'm going to add a comp 3D. So I'm going to take our neat shot into the tracker, delete the trackers that are there, and add in 2 trackers to follow. So I'm going to select comp 3D and axis 2, and this time, with all my parameters enabled, I'm going to hit stabilize. Now the difference between move and stabilize is only one of inversion. With move, if the trackers move to the left, the data moves to the left as well. With stabilize, it does the opposite, it moves to the right. It does a counter move. So if I exit the tracker and look at comp 3D, you'll notice that I've broken the rule of having a background before my comp. So the result is no stabilizing is happening because the comp believes this is the background. So this is an example where I might go into options and switch off background. So now the first input the comp 3D gets is a layer, and you can now see it's doing the stabilizing. So it's holding this point and this point still and applying in some rotation to keep them at the same angle to each other. You can see that we're getting the edge of the frame come in, where Mistika is having to move the frame so much to hold that particular position. Mistika doesn't automatically expand the frame for you, so you'll need to do that by zooming, and as before, you'll need to do the zoom before the motion tracking is applied. If you do it after, you'll undo your stabilizing. Going back to tracking, the third mode of application was smooth. Whereas move and stabilize will apply exactly the tracking data, smooth looks for any abrupt changes and removes them. So the purpose of that is, for example, to remove camera shake without actually stabilizing a shot. You can also do that manually by using a combination of effects here. So here I have in axis 2 the stabilization. But actually, if I started to apply moves in the axis here, you can see that I'm creating a move. Let's exaggerate that to make it more obvious. I'm creating a smooth move because the curve in axis 2 is removing the original move altogether, but the curve in layer is a linear move. So this is also a way of smoothing out a shot. When we export our curve to whatever the recipient effect is, whether it's comp 3D or shape or title, framing, anything that has XY move, then the frame on which we park when we export is relevant, because on that frame the data will be arranged in such a way that X and Y are 0 at that point. It's probably easier to give an example of why that's useful rather than try to explain it. So let's say in this particular shot I have some branding here that I want to get rid of. So the process I'll use is that I'll use the cloning brush in vector paint to paint this out. But I don't want to do that on every frame, because if I'm using manual paint strokes, if I don't do exactly the same paint stroke every time, we'll see my paint stroke animate. So what I'd rather do is paint on one frame, clean it completely, and then track that bit of the frame onto the rest of the shot. So what I start by doing is pick a suitable frame. Let's just get this on. So let's say I'm going to paint on that frame. So I'm going to make it a frame long, and then by hitting G for group I can freeze it. So I've now got that shot as a frozen frame compared to that one that's moving. And now I'm going to go into vector paint, double click, paint. Just need to make sure I'm on apply image, and I choose the brush as clone foreground. I'm just going to do this roughly, so I might make a bit of a mess. Change the brush size, press Alt to grab an area, and now I'm going to paint over there. Talk amongst yourselves for a minute. A little bit rough and ready, but it'll do for the demo. Okay, so we've got rid of our branding on one frame. So if we go back to our timeline, we can see that we have a frozen frame with no branding. So what I now want to do is cut out just that bit of frame and track it onto this shot. So the cutting out bit is easy, we know that because we've done that with shapes before. So let's double click on here, we have shapes. Clear the existing alpha, add a new shape. And let's just make life easy for ourselves, and we'll just cut out this area here. I will no doubt want to blur that a bit. Let's blur it on the inside. And in fact, I'm going to change the tangents so the blurring is more left to right. Okay, maybe it's the right place, I'll worry about that in a minute. So if we put a comp 3D, what we'll see is that we've got our cutout stuck over our frame, but of course it isn't moving. So let's take our neat shot into the tracker and get some tracking marks up. Now incidentally, when you're tracking for rotation and scale, you'll be much more accurate if you can keep these as far away as possible from each other, for the reason that if you have them very close, any small error in the tracker, as you can see, creates a big angle change, whereas the same thing over here creates a small angle change. That said, I'm just going to track either side of that and see what happens. So having got my tracking data, just for argument's sake, I'm going to park on frame 0. So what I want to do is apply this tracking data to the comp 3D, because that's what's moving around my little cutout. So I'm just going to select it, and on frame 0 I'm going to apply. So now what we can see is we've got it's tracking, but it's moved, it's got an offset. The reason that happened comes back to the point I was explaining about the relevance of the frame on which you export. If we go back to the timeline, we can see that we did our painting on frame 13. So if we go back to the tracker but do our export on frame 13, what we can now see is our patch is sitting nicely over the whole shot. And the reason for that is this. On frame 13, the frame that we chose to export, look where all the points are. They're all at 0. X, Y, rotation, everything, scale, all at 0. So that's how we can ensure a reference point when we reapply our tracking. We simply pick the frame where all the data is in Unity. Let's just return to tracking to look at all of the functions that we have here. We've seen that we can restrict the ranges either by typing in numbers or setting the frame that we're on at the moment, and the go-to will jump to those frames. We can add extra trackers. We've looked at 1 and 2 point tracking. We can add as many trackers as we like, and so long as we're applying position, rotation and size, Mistika will take an average of all of them. So in some instances it can increase the accuracy of the trackers, other times not. There's a specific case for 4 trackers called corner pinning, and that's used where we're trying to record the perspective change of something we know to be a square or a rectangle. We'll look at that in the next tutorial. We can obviously delete trackers. We can clear the range that the tracker has recorded, so if the tracker has gone wild, that's the easiest way of removing the path that it's created. And we saw the use of search zones. These are all self-explanatory. We can save and load paths, and actually it's good practice as you track shots to save the result, for the reason that the tracking interface holds one curve. So if you're on shot 1, you track it, you export it, all good. You move to shot 2, track it, export it, great. But now you want to go back and change shot 1. You have the data on your timeline, but that doesn't translate to where your tracking points were. So if you want to get back your tracking data, you'll want to load the track that of course you saved. Do tracking we looked at, go forward from the frame we're on, backwards, going both directions one after the other. If search zone is on, both gets disabled, because it's envisaged that you would use search zone when you're manually trying to help Mistika locate the pattern on the next frame, in which case you'll want to know which direction it's going in. You can stop the tracking process and track one frame at a time. Then there's a drop down for removals. You can remove the keyframe that it's just created in the track. You can remove the range, which is the range between those two, for any given selected tracker or trackers. You can remove beyond the current frame or before the current frame. Apply we looked at. We can also save the shape the trackers create. And then we can import that shape into vector paint. For example, if I were to create some random shape out of the trackers, and track that, I could actually save the shape and then in vector paint I could load up the shape. It naturally goes into the output folder of your particular project. So now we have that as a vector shape which we can modify. Silent tracking is an interesting one. In the pursuit of optimizing Mistika, the developers found that one of the slowest parts of tracking is loading up the image onto this display so that we, the operator, can see what it's doing. If you press silent tracking, the trackers will work, but the screen will not be updated. They'll track a lot faster, but you won't be able to see what they're doing. So, for example, in silent tracking, if I put a tracker on here and press both, let's just zoom in so we can see it, You can see there's no update, but the track appears. And if we're working with high resolution frames, we can choose whether the trackers will be looking at the full resolution or the proxy resolution. And likewise, when we're scrubbing through, we can switch our scrub to switch to dynamic, which might speed us up if we're working with very high resolution frames. We can also choose whether we're showing the path that's been created, or in the case of having multiple trackers, we can also choose whether we see the shape that's being generated. So in the next tutorial, we'll specifically look at corner pin tracking and see how that works.